Hey, Mitch.
Hello.
How are you? Sorry about that.
It's fine.
It was weird. It happened right as I was ending my last session, which is better than if it had been in the middle of the session, but still an inconvenience to you.
Yeah. Oh well.
All right. We want to start with 25 here?
Yeah.
What's this thing over here? Is that for 26 maybe?
I don't see it yet.
This graph
But it's,
that we're looking at here. In other words, question 25, I presume, pertains to this graph.
yeah.
Okay.
Yeah, and then there's 26 right next to it.
Okay. I see. I see. We need to write an equation of both of these. I get it now. Okay.
Yeah.
All right. Let's look at the one on the left for starters.
Computer's really slow.
Is there a lag between what you're seeing and...
Yeah.
Okay.
Like, really bad.
Is it really? Wow. Huh. Maybe that's why my computer went haywire. Maybe the internet is slow.
I can hear you fine though.
Okay. All right. What's the general equation of this parabola? What is the general equation of a vertical parabola like this?
Would it be... I don't remember.
Well, different schools do it different ways, but... Oh, man. There's the general equation that's going to work the best on this problem. Okay? Now, the other equations you have for a parabola are this. Remember, this is vertex format.
I don't see it.
Okay, wait a second. See if you do. Tell me when you see the vertex format. Let me close this program out. That might help a little bit.
I just see it. I just saw it.
Let me close that out. That should help a little bit. Okay, tell me when you see the number 1. That much lag. You still don't see the number 1 on my screen?
Nope.
Wow.
But I hear you fine, so
Okay.
it might just be your computer.
All right, we should be able to go forth. You see this vertex format?
Yeah.
That's the traditional.
No.
That's the traditional format that you have used for parabolas forever. But the moment you start talking about parabolas in the context of them being conic sections, where you have a focus and a directrix, they generally change the format to the top format. Which did your class do? Do you use the 4P?
No, we use the bottom one.
Okay. That's fine. We can use the bottom one, but notice that the bottom one is going to be A will equal to 1 over 4P.
All right.
Let's look at the top first, and then we'll switch to the bottom. But maybe you can see the advantage on why you would use the top when you're dealing with parabolas that you need to find stuff like focus and directrix. What's the focus going to be equal to if I look at the top formula? What is P? P is the distance from the vertex to the focus, or the distance from the vertex to the directrix.
All right.
So looking at our graph, what is P?
would be 8.
Yeah. What's K and H?
Would be 0 and 0.
Okay, so here's our, using that general format, if I know P is 8, then I've got 32 times Y equals X squared. Now, if I want to put that into your more normal format, I'm going to divide both sides by 32, and I have this is your equation that you're looking for.
Okay.
Okay? Now notice I could have gotten this answer without using that format, but I would have had to know that A equals 1 over 4P. In other words, if you're going to use this format everywhere, then let's do that. But you have to know how A relates to P. So if A equals 1 over 4P, and I know P is 8, then A is 1/32nd. And I can apply it directly to the new format. I mean, your old format. In fact, it's a little more direct. So it doesn't matter which format you use. You can use either of these formats. The key to know is how to relate A to 4P. And obviously, I would need to divide both sides by 4P to end up with an A. Let's do another one, and maybe it'll become a little clearer. Let's do the one on the right. Hold on. 26. This time, we'll use your format only. But we do have to still remember that A equals 1 divided by 4P. What is the center? What is H and K for 26?
Is it -6 and -4?
Yeah. Yes. What is P? Okay, so what is A?
1 over 24.
Okay. Now we're ready to write the equation. Y equals 1 over 24, that's A, times what?
Times x minus x plus 6. Or -4?
There you go.
Wait, so is H and K like...
H and K are the vertex, they're the vertex, the coordinates of the vertex.
Okay, so is H always the x value?
Yes.
Or
Yes, H always goes with X, K always goes with Y. Whether you're talking parabolas, circles, ellipses, hyperbolas, H always goes with X, K always goes with Y.
Alright.
Now, just so you can see, I'll do it the other way, where I have 4P times the single variable equals the variable that's being squared. Well, if I go through the exact same math, where P is 6, then I have 24 times Y plus 4 equals X plus 6 squared. Well, if I do that math, Yeah, I divide everything by 24 and then I subtract 4. I get this. In other words, I can go from that to this. And this one came from this general format. So you can kind of see why somebody changed the format to this 4p thing. It makes it actually easier when you know the focus length or the directrix length or things like that. At least I think it does. I don't know. I have my doubts. I almost prefer going with the original format and just knowing that A equals 1 over 4p. All right, let's look at 27. Now 27 is where we might be better served going with the newer format. And the reason is that this is not a classical parabola. The classical parabola that we're used to dealing with is this one. When they're horizontal like this, and they're not vertically up or down, that's this parabola, x equal y squared. It's kind of the inverse. Okay?
Yeah.
So we don't really know what the general format of that one is. I mean, we do know it's this. But you're not used to this format. And I can take the h and put it over here if you like, and take it away from that. So now I got x equals a times y minus k squared plus the h.
All right.
And still a is equal to 1 divided by 4p. What's h and k in this parabola?
0, 0 again.
Okay, what's p?
5/2.
Okay, so if I plug in 5/2 for p, I get 1 over 10. So a becomes 1/10. Everything else is spelled out. So the formula is x equals 1/10 times y squared, except for one problem. If the coefficient is positive, it opens to the right. If the coefficient is negative, it opens to the left. So I need this to be negative. Negative 1/10 y squared. And now I have a sideways parabola that opens to the left. If this were a positive 1/10, it would be this kind of a parabola. It would open to the right.
All right.
So these problems all come down to memorizing the general format of horizontal and vertical parabolas and knowing that a is 1 over 4p. And knowing that if it opens to the left, it needs to have a negative coefficient. If it opens to the right, it needs a positive coefficient. Those three things are the only things you have to know to answer these questions.
All right.
We need to go to another page,
Yeah.
but 28 is still writing the equation of a parabola. Oh, no? Is this the next page?
But it's all like combined because they copied them out of the book. But none of them are like, they're all just problems I had trouble with.
Okay. So does it matter where we go next?
No.
Is this fine?
Yeah.
Okay.
Like, we did this stuff in class, and I had no idea how to do a couple of these.
Okay. If you're still confused on the parabolas, we'll go back before we get done today. Make sure we cover most of the stuff that you're kind of confused at. Okay, first of all, how do I solve that?
You could, because it won't factor.
Actually, it does.
Like,
Factors nicely. It's the first step of factoring.
just putting the x's on both sides.
Separate this term, yeah.
Yeah.
Second step.
Figuring out the signs.
What are they?
So they're both negative.
And now we need what? Factors of 40 that do what?
Add to equal 13.
That's 8.
Subtract.
That's 8 and 5.
Oh. Okay.
So what are my two solutions?
Positive 8 and positive 5.
And their question says, what is the sum of the two solutions?
So it would just be 13.
13. Positive 13.
All right.
You need to look at 5, 6, and 19, or just 27 through 30?
Just 27 through 30.
Okay. What's the elementary function in 27?
Is it just x squared?
Yeah. So we need to figure out what's going on to this that's different than my elementary function. I got three things that are happening. What is the effect of that?
It's moved up one?
Yes, without changing its shape. In other words, it's just a vertical shift. What's the effect of this?
It's moved left one?
Left 2.
Or left two, I mean.
Okay.
Yeah.
Without changing its shape once again. In other words, if our original parabola is like this, then the 1 moves it up 1, and the 2 moves it over to the left 2. So same shape, it's just moved up and over. Now what's the effect of the 3?
Is it a vertical stretch?
Yes. What effect does that have on the shape? To make it skinnier or fatter?
Yeah, it makes it skinnier
Right.
and rise higher,
Well,
faster.
yeah, skinnier. They both go up to infinity. But
Yeah,
it's
that's
definitely a skinnier parabola. Okay, so that's the only three things that are doing. Now, it also says, describe the transformation and then identify the vertex. Where's the vertex?
Is it just -2, +1?
Yep. It's H and K, -2, +1.
Okay.
All right, let's look at 28. Not much different. What three things are going? Well, there's four things going on in 28. There's one extra thing going on. What is it?
It's flipped over the
Over
x-axis.
right, over the x. In other words, if my minus sign was in front of the x and inside the parentheses, that would be a flip over the y-axis. But since the minus sign is in front of the elementary function, that's a flip over the x-axis. So where's the vertex at this thing?
It's is it -1, +5?
Yep. There's my vertex, minus 1, positive 5, and I know the thing goes down. So I've identified my vertex, but let's finish describing the transformations. So we have a reflection over the x-axis, that's number 1. What else? What other 3 things do we have?
We have a vertical stretch by 4, and we have a move left by 1, and then a move up by 5.
Move down by 5, right?
Move down by 5, then you flip it, and then it ends up moving up by 5.
Hold on a moment.
Because when you flip it, it moves up.
Hold on.
Right?
Well, let's look at this, because now I'm confused. In other words, if this is our elementary function here, I know the very first thing you got to do is flip it. You do all reflections first. Okay? So that's the effect of the negative sign. Now let's make it narrow. So that's the effect of the negative sign and minus 4. And now move it left 1 unit because of the plus 1. So it puts it there. And now move it down 5. What's the general format for a parabola?
Yeah.
Plus k.
All right.
So k was minus 5, not plus 5. So when I originally graphed this thing based on its vertex, I was wrong. Its vertex is minus 1, minus 5, which agrees with the order of operations that we just did. In other words, I need to end up down here.
Okay.
And as long as I did the order of the operations in the proper order, I did end up down here. My mistake originally was plotting the vertex at minus 1 plus 5 instead of minus 1 minus 5.
All right.
Okay?
Yeah.
29. Translations?
It's a vertical stretch by, or it's flipped over the x-axis, then a vertical stretch by 2,
Okay.
and then moved up by 5.
Uh-huh. So this becomes very easy to graph. In other words, flipping over the x-axis, making it skinnier, and then moving everything up by 5 gives us that. And that vertex is 0, 5. And you could read the vertex. In other words, if I say that's in vertex form, well, clearly h is 0 and k is 5. Number 30. Where's the vertex?
The vertex is just 1, 0.
What two transformations are happening to our original function?
Right.
In other words, if this is our original function here, what two things are happening?
It's moved right 1, and then it's a vertical shrink by 1/2.
Yeah, which flattens it. It has the effect of flattening the parabola. Instead of making it skinnier, it makes it fatter. So there's my this function graphed.
Yeah.
I've looked at all three papers you sent me, have we not?
Yeah. Yeah, we have.
Okay. You got some you want to verbalize, or you want to send me more? Or?
So I remember doing stuff in class where we had to find like the focus
Okay.
when we just had
Let's do
like
one of those, because we haven't really done one of those yet. I'm going to give you one, and you tell me what the focus is.
So
this is, first of all, in the format. It's in this format, not my other format. But in order to figure out the focus, you have to know the relationship between A and the focus.
all right.
So what is A equal to in terms of the focus?
1/4p?
Yeah, where P is the focus, length.
Oh, okay.
Okay? So in this case, we have 2 equals 1/4p. So what does P equal?
P equal, crap. So
Starting from that right there, solve for P.
it would be 8. No.
Yeah, no, that's okay. Do the first step. You don't need to do this all in one step. Do it in 2 steps.
Okay, so you multiply it out, so it would be 8p equals 1, and 1/8. P equals 1/8.
That's what it would be.
Okay. And now it'd just be
Just remember that A equals 1/4p. Or you could even say P is equal to 1/4a. In other words, if I solve that equation, I get P equals 1/4a. As long as you as long as you can make those conversion, then you can get away with using this format. You don't have to go to the 4py format. And incidentally, when you do go to that other format, the 4p always goes in front of the variable that is only being taken to the 1 power. In other words, it goes in front of the y. If it's y equal x squared, it goes in front of the x if it's x equal y squared. Let's do one more like that. Let's make sure you can figure out the focus of a given quadratic. Do you have one?
No.
Well, let's go back and pull up the ones from that page we were just on. Let's figure out the focal length of each of these. 27, what is P? What's the focus equal?
It's 3 equals 1/4p. So it's P equals 1/12.
Okay. Now, I want you to give me the coordinates of the focus. First of all, where's the vertex of this thing?
-2, +1.
We know it opens up. What's the coordinates of the focus?
Is it -2 and then +1 and 1/12?
Yeah, or 13/12. That's exactly how you do it. What's the equation of the directrix?
Would be y equals 11/12.
Uh-huh.
Alright.
What's the focus on 28?
So it's 1 over, or it's -1/16.
Okay, when you get a negative sign in front of your focus, all it means is that the distance from there to the focus is going to be measured in a downwardly direction. In other words, we know that this negative sign means we're talking about a parabola that points down. So we automatically know the focus is below the vertex. Well, you got 1/16, right? -1/16 for your focus?
Yeah.
Which means it's 1/16 below the vertex. And the directrix is 1/16 above it. So I tend to like to talk about focuses as an absolute value, as opposed to having a sign. In other words, I wouldn't have said the focus is -1/16. I would have said the focus was 1/16. Then I would have graphed my parabola, and I know that my focus is below my vertex. So I don't have any problems placing the focus. It's just how you talk about it. How do you measure this distance between there and there? Well, to me, that's just P without a sign. And it's just P to there also without a sign. I suppose you could say that the directrix is +1/16 away from the vertex, and the focus is -1/16 from the vertex. So it does make sense with a sign in front of it, but not sure it's necessary, as long as you think of it as an absolute measurement.
Yeah.
Do one more. What's the focus on 30?
So it would be, it's 1/1/2 goes 1/. Here, let me write this down.
So what's the general formula for focus in A?
So it's A equals 1/4P.
Okay. A here is 1/2. So solve that for P.
So 8. I got P equals 8. Doesn't make sense.
No. Let's solve this. Cross multiply.
Oh, I forgot to cross multiply.
4P equals 2. P equals 1/2.
Oh, okay.
Okay. Now it's just coincidence.
Yeah,
It's coincidence that P is equal to A here. I guess it's always going to be equal to A whenever A is 1/2, but it still is coincidence.
All right.
Okay. Are parabolas the only thing that you're covering in your test, or you do any ellipses or hyperbolas also?
I think we're doing all that. I just didn't. I get all of them except parabolas. Like parabolas.
Okay, I don't blame you. Parabolas, especially when they throw in that 4P, it really messes things up. What's the general equation of a circle?
Isn't it just r squared?
It's x minus h squared plus y minus k squared equals r squared. In other words,
I don't remember doing that at all.
well, maybe you're not covering circles and ellipses. Have you seen anything that looks like this?
We've seen it, but he said it wasn't on the final because he didn't explain it.
Okay, good. Because that is at least 2 sessions worth of material. Maybe 3. 3 half-hour sessions worth of material. So that we don't have to cover this is a good thing. So the only thing you have to worry about is parabolas. So give me the 2 formulas. What's the general formula for what I call a vertical parabola?
So would that just be 1 over 4p and
Okay, I like that thing.
and parentheses y minus k.
Well, okay, no, that's okay. You could put the y minus k, but then you add the k to the other side, and it becomes that.
All right.
And this fits the general format of a parabola. Remember this? That is the vertex format for a parabola.
All right.
So the only difference when we're talking about parabolas where we care about focuses and directrix is that we replace the a with 1 over 4p. Well, now that is what I call a vertical parabola. It either looks like this or it looks like that. What is the general format of a horizontal parabola? A parabola that either looks like that or looks like that.
It's x equals either 1 over 4p or a, then y minus h.
K. K always goes with y.
Oh,
Always.
oh, okay.
Don't ever put an H with a Y or a K with an X.
All right.
And again, if this term is positive, it opens to the right. If it's negative, it opens to the left.
All right.
Call that a horizontal parabola. Notice that horizontal parabolas are not functions. That fails the vertical line test. It's okay. It's called a relation, not a function. And it still has lots of good uses that we can talk about. In other words, it's still very effective to treat it as a whatever it's called. But it is not a function.
All right.
Okay. Anything else?
And then I just have some arithmetic sequences.
Okay.
They're just the first 5 steps
What's
of
the
an
nth
arithmetic.
term of an arithmetic sequence? What's the general format?
Would just be a equals a of n equals to a of 1.
A sub 1
So
plus
the n.
some common difference times n minus 1.
Oh, okay.
No matter what the arithmetic sequence, it fits this. Okay, let me give you an arithmetic sequence. Now, the definition of an arithmetic sequence, that's not an arithmetic sequence. Every single term has to be separated by the same amount. That is an arithmetic sequence. If I said, what's the 5th term of this arithmetic sequence, plug it in and let's see if we get it. We know it's 14, but let's see if we can get it based on this definition.
So it'd be 2 plus 3, then 5 minus 1.
That's 14.
All right.
Now, they can make problems that are relatively difficult with arithmetic sequences. For example, if I said the third term of a sequence is 8, and the fifth term is 14, and that is the only information I had to go on, you could figure out the sequence. We don't know n, and we don't know d, and we don't know a sub 1. But I can write two equations and two unknowns. In other words, if I know the third term is 8, then I can say 8 equals a sub 1 plus whatever its common difference is times 2. And if I know the fifth term is equal to 14, then I can say 14 equals a sub 1 plus whatever the common difference is times 4. N minus 1 would be 4. Well, now, that gives me two equations and two unknowns. I can solve this. So all I have to do is subtract the first one from the second one, and I get 2d equals 6. So the common difference has to be 3. Once I come up with the common difference, I can figure out that a sub 1 is 2, and I have my specific. In other words, this is general. The specific formula for the sequence that I wrote up there would be 2 plus 3 times n minus 1. But now notice that I have to reduce that, simplify it. In other words, for the sequence that I wrote, 2, 5, 8, 11, 14,
Yeah.
if I said what is the specific nth term formula, well, I would substitute 2 for a sub 1, I would substitute 3 for d, and then I would reduce this. Well, that is 2 plus 3n minus 3. So the final thing is 3n minus 1. So there is the nth term for that particular sequence. You plug it into the general, and then you simplify, always.
All right. That makes sense. That makes sense. That makes way more sense than what he explained it as.
Let me give you a sequence and have you give me what its specific nth term would be.
So you would plug 3 in for a sub 1, then 4 in for d, and then so it'd be 4n minus 1.
So that I would call the specific nth term definition for this sequence. This is for all sequences, no matter, as long as they're arithmetic. This is true for all arithmetic sequences, but this would be true just for this sequence.
All right.
Have you had the sum of a sequence? Have you had, did they make you memorize that yet? In other words, if I wanted to know what the sum of the first 3 terms of this sequence are, just tell me if you've had it, and if you had, we'll go over it. If you haven't, we'll ignore it.
No.
Okay, we'll ignore it. But you might imagine that that might be useful. If I said, what is the sum of the first 100 terms of this sequence? So all I need to know is the first term and the last term. So first of all, I'd have to figure out what the last term was by plugging it into this, or into its specific definition, which was 4n minus 1. So I could figure out the 100th term by plugging it into 4n minus 1. Then I would have the first term and the last term, and I could plug it into my sum formula. What else? Anything, Mitchell? I'm going to have to go at 5 just because I have sessions back-to-back until 9 o'clock tonight.
No, not anything that we need to go over tonight, because we'll go over in class tomorrow, but I'll probably end up having it. You help me tomorrow night.
Okay. I will talk to you tomorrow night.
All right.
All right, bye-bye.